This is the new proof of concept for the flat camera, the instant on flat camera. The secret sauce is that this dev board has an STM32N6, which is a pretty new ARM from STM that has a built-in MIPI CSI port. And that is really the magic that makes this work. So we can directly feed the image sensor using MIPI into that chip. This is an IMX335 sensor, which is not a very good sensor. The only reason I picked it is because there was an example in the SDK for the chip that used that to do like AI image detection. So it was just possible to steal all the settings for that image sensor from that code without knowing what any of the settings were. And it turns out those settings are good enough for taking pictures, but otherwise this sensor's terrible because it takes like 70 milliseconds to warm up. I'd much rather use a global shutter sensor that warms up almost immediately. This is just a USB power pack, but importantly, the power pack is connected to the dev board through the shutter button. So literally the dev board is not getting any power right now, and pushing that button connects the USB to the dev board and powers it up. And so when you push that button, it powers up, it initializes the sensor, grabs a frame, and then displays it on this LCD screen, which just for now, just so we can see that it's working. On the real flat camera, there would not be any LCD because it actually takes time also to initialize the screen and put the image on it. So let's see how it works. So you pick it up and we'll go over and we will take a picture of Miles. Miles, make a pose that we could never have pre-rehearsed. Hurry, everybody's getting impatient. 1, 2, 3. So that is the pose that Miles made. That the total time from power until you see the image is about 102 milliseconds right now. And again, of that, 70 of it is just waiting for the image sensor to come on, so we can get that down to less than 50 milliseconds. It's already basically imperceptible. I mean, you push the button and the image pops up. You see the LCD emitting for maybe 20 milliseconds. And that's it. And so what in the real one, what would happen is every time you push the shutter button, it would wake up, power up the sensor, take an image, and then copy the image onto an SD, and then go back to sleep. But you as the user would not know that was happening. You would just think you're clicking pictures, boom, 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 and each time you click, they would go into the SD. So that is the proof of concept. Really ugly, but I think it's all there to prove that it would work and be viable.